Okay, this is the video for the optimization problem, the second video, which I continue from question 12 to question 19. So look at the question 12. The function y in terms of a, in terms of in the variable x, but in terms of a, the a is stay as unknown, has a minimum value of 6. Find the value of a. So here it gives you the information, minimum value of 6, meaning that we need to get a dy dx, and we make one equation equate to 6, and then later on we solve for the a. Get your dy dx as your 2x minus 2, and let your dy dx equals to 0. You have your dy dx equals to, you have your x equals to 1. Minimum value is referred to the y value, which is we say that the y value at the minimum point is 6. From here, dy dx equals to 0, we solve, we got x equals to 1, meaning that this is a minimum number. This is a critical number, which is at the minimum point, we have the x coordinate x equals to 1. So here we have, we can say that we have a minimum point x equals to x equals to 1 and y equals to 6. This is the minimum point. And I need to get the a. I form one equation. I substitute the x equals to 1, y equals to 6 into the function itself, which is x squared minus 2x plus a. I put in my x value and y value, y as a 6 and the x as 1. Then I can solve for my a, which my a is a 6 minus 1, 5, 5 plus 2 will be 7. Question 13, we have y equals to ax squared plus bx, where we have two constants to find, which is the value of a and b. And the question told us that the function has the maximum value at the point x equals to 2, y equals to 3. This is the x value, this is a y coordinate and x coordinate, where the x coordinate is 2, y coordinate is 3. It gives you if it gives us two information. No, we need to form two equations in order to find the two unknowns. First, the information we can substitute x equals to 3, y equals to, x equals to 2, y equals to 3 into the function. We have 3 equals to a, x will be 2 squared, and plus bx, x will be 2. Simplify, you have a 4a plus 2b equals to 3. This is your first equation, and we cannot do anything with this single equation because two unknown to be found, and we need to find another one equation, which I will take this information. Maximum value at 2, 3, meaning that we need to find dy dx so that we can apply this information. Dy dx equals to 2ax plus b. So when I let the 2ax plus b equals to 0, I solve for the x. X is the value of the extremum points. Okay. Here I solve the x. I solve for the x. I got the x equals to negative b over 2a. And for this x equals to negative b over 2a, I will equate the negative b over 2a, equate it to be 2, because this is a maximum value. Alright, then I have negative b over 2a equals to 2, because this is given as a maximum x coordinate of the maximum point. So here I have 4a, negative b equals to 4a, and the b equals to negative 4a. Then I have my second equation. Combine, solve the simultaneous equation of equation 1 and 2. And I substitute the 2 into equation 1. I might solve for the a plus. I got my 4a plus 2b. b, I will substitute the b as a negative 4a equals to 3. Substitute the equation 2 into 1. I got this. Then I got my 4a minus 8a. I got negative 4a equals to 3. So a equals to negative 3 over 4. And to get the b value, just substitute the a as a negative 3 over 4 into the equation 2. B is equals to negative 4. multiplied by a is a negative 3 over 4. So just simplify it, you will have 3. Final answer, you have the b equals 3, a equals to negative 3 over 4. Here is a question. Gives you a box cuboid framework as shown below is 96 cm. 96 cm given as the total length of the wire. Alright, we are using a wire with the length of 96 cm, and we bend it, we form a cuboid framework. Find the maximum volume of the outline of the framework. So volume, we need to find the maximum volume, means we need an expression on the volume of this cuboid. So to get this cuboid volume, I will use the formula which are finding the volume of a cuboid, which I will take the length multiplied by the width, that is the area of the base, multiplied by height. So the area of the base will be 3x multiplied by x, and multiplied by the height, that will be y. So my v will have a 3x squared y. This is the expression for the volume. Okay, so to get the maximum volume, I need to find either dv dx or dv dy. So looking at this expression, we know we need to dump one of the variable to make it single variable. So how do we make it single variable? We are going to use this information, 96 cm. Because the length, the total wire that we use to make this framework is 96 cm. So we need to form one equation which can relate the relation between the x and y and equate it in with the 96. Alright, so how do you form this equation? We know that we have 3x, this is 3x, this is x, and all these are the y. The height of the cuboids are the y. So we have 3x plus 3x plus x plus x. That will be all the wire needed for the base of the cuboid. And we have this is just like cover. This is just like cover of the cuboid. We have 2 pieces of this. So we multiply this by 2. Okay. And after that, we have 4y. We need a wire for this the height of the cuboid. So we need 4 times of y. And we have all this made by the 96 cm of the wire. So we equate it with the 96. And now we're trying to simplify. We have 9, 10, 11. Okay, sorry, 6, 8. 8x multiplied by 2, that will be 16x plus 4y equals to 96. Simplify, divide both sides by 4. You have a 4x plus y equals to 24. Alright, this is my, you can say that this is your first equation, or I will make this y into the subject. So y equals to 24 minus 4x. Why I need this? Because I need this to substitute into my v, so that my whole expression for the v will become all in terms of x. Alright, so now we're trying to substitute this equation 1. I note this as a 2. Substitute 1 into 2. I got my equation become like this. V equals to 3x squared. So y substituted as a 24 minus 4x. Then you might expand it so that easy for you to differentiate. We got a v equals to 72x squared minus 12x cubed. To get a v maximum v, we need to find the dv dx. And then later on, we let the dv dx equals to 0. So I have 144x minus 36x squared. And later on, to get the maximum v, we let the v dx equals to 0, meaning that 144x minus 36x squared equals to 0. Okay. Divide both sides by 4. By 36, you have a 4x minus x squared equals to 0. Then you can factor out the x. You have a 4 minus x equals to 0, then you have a one answer, x equals to 0. The other one answer is x equals to 4. Then we need to test by a second derivative test. By using second derivative to prove that this x equals to 0 or x equals to 4 will make our v to be either maximum or minimum, and we need the maximum. Alright, so get your d2v dx2. You have a 144 minus a 72x. Then when your x equals to 0, you got positive, meaning that your v will be minimum when the x equals to 0. Alright, so now I just know that I need to substitute the x equals to 4 inside to prove that this is a negative value. Alright, you will get a negative value. So once you get the d2v dx2 equals to a negative value, so you can directly make your conclusion. V is maximum when x equals to 4. And now we need to get the maximum volume of the outline of the framework. We are not interested on the x equals to 4. We actually want to find the V maximum. So just put in your x equals to 4 into the expression of the V, which is you have here 72x squared minus 12x cubed. Alright, so this is your 72x squared minus 12x cubed. Substitute the 4 inside. Then that will be the maximum volume, which you will get the V maximum to be 384, and the unit should be, okay, this is in cm, meaning that the unit should be in a cm cube, because it's volume. Question 15. A stone is thrown up. Its height h meter from the ground after t seconds is given by h equals to 96t minus 16t squared. Determine the maximum height of the stone reaches. Alright, so for this question, this is a very simple question. We need to find the dht, and the h already in terms of single variable. We just find the dht. We got 96 minus 32t. And then let your dht equals to 0. Solve for the t. You have a 32t equals to 96. And we have a t equals to 3. After that, we need to check with the d2h dt2, which is my second derivative. Find the d2h dt2, we got negative 32. So the second derivative, if the second derivative is negative, means that we can say h is maximum when t equals to 3. So the question asks us to find the maximum height of the stone, means that we just find h maximum, which I will substitute the t equals to 3 into the the expression of the h, which is 96t minus 16t squared. T substituted as a 3 and calculate, you will get the answer, which the answer is 144, and the unit is in meter. Let's move to question 16. 80 meter of wire is used to form a rectangle. Find the largest area enclosed by the wire. So I will use this, I will just sketch a diagram representing the rectangle which is formed by the wire. And the rectangle consists of the length and the width. So because of the 80 meter of wire is used to form this rectangle, so I will say that the parameter, which is a 2L plus 2W, will be equals to 80. If I simplify, I will have 40. L plus W equals to 40. Find the largest area enclosed by the wire. So what we're interested is the largest area, means that we need an expression on the area, which the area is equals to the length multiplied by the width. So to get the largest area, I need to either differentiate the A with respect to L or differentiate the A with respect to W. So I need to decide which of the variable need to be done. So here I will find L in terms of W. I got my 40 minus W. L equals to 40 minus W. Substitute inside here, I have my A equals to 40 minus W multiplied by W. So now you have successfully made A in terms of W only. Just expand it. Easy for us to differentiate. Now I need to get the largest A. I need to find the ADW. The ADW, you have 40 minus 2W. Then I will make the ADW equals to 0 in order to solve for the W, which will make my A to be maximum. Okay, so get your 2W equals to 40, W equals to 20. Okay, and I'm not sure that this W equals to 20 will make my A to be maximum. I'm not sure. I need to check with the second derivative. Okay, check with the second derivative, meaning that to get your D2A dW2, you get negative 2. So since your second derivative is negative 2 and it is less than 0, we always say negative. So we can make conclusion A, which is the area, is maximum when the W equals to 20 meters. Okay, then the question is not interested on the W only, but it want us to find the largest area. Means that we need to get the A max. A max will be the 40W, which multiplied by 20 minus 20 square. I will refer to this expression. Then I have 40, 800 minus 400. I got 400 meter square. Okay, that will be my maximum value of the area. For question 17, I have this sector. Let's read up the question. The above diagram shows a plot of land having the shape of the sector of a circle with the RCM is the radius, and the angle subtended at the center of the circle is theta radian. The sector is enclosed by 100 meters of fence, meaning that this line, this information, which gives you 100 meters of fence, this means that this line, okay, the length of this sector, and plus the radius will be equals to 100. So I need to form one equation, which I need to get this length plus the 2r, which is the 2 radius, equals to 100. Okay, so how do you get the length of this sector length? I have my arc length. We call this as arc length. The arc length for one full circle is 2 pi r. Okay, then I will need to get, because this is not a full circle, this is just a sector with this angle subtended by this sector is theta. So I will multiply this by theta over 2 pi, because this is just it's just like theta over 360, but now we're dealing with the radians, so I will take the theta over 2 pi. And if you simplify, you will have r theta. Means that the length of this arc is r theta. So from here, I will say that r theta plus the 2r, which is the 2 radius, will be equals to 100. This is one of the equations that I can form from this information. For the question A, show that the area of the sector, which is a meter square, is given by this. So to get the area of the sector of this sector is pi r square. Pi r square, which pi r square is a full circle, is the area of a full circle. I have a pi r square here is just a sector, so the area is given by pi r square, again multiplied by theta over 2 pi. And if you simplify it, just cancel off the pi, I got my r square theta over 2. This is the area that I got. My area is in terms of r and theta. But look at this statement that the question wants us to prove. This statement is just containing the a in terms of theta. So we need to find ways to eliminate the r over here. How do we eliminate the r? Still remember, we have formed one equation on top here, which r theta plus 2r equals to 100. I write down here. R theta plus 2r equals to 100. From this equation, I can factor out the r. I got the theta plus 2 equals to 100. So r actually can be written in the form in terms of theta, which I have 100 over theta plus 2. Now I'm going to substitute this r into here. Substitute the r square as 100 over theta plus 2. I got 100 over theta plus 2 square and multiply by theta over 2. I'm going to simplify it, and I hope that I can get this statement. After simplify, I have 100 square. I got the 10,000, and the theta I write it down here, and over the theta plus 2 is actually square, and put it as a denominator, and down here also there is a 2 down here. And now simplify the 10,000 and the 2, I got the 5,000 on top, and this is producing 1. Write down the final answer. I got 5,000 theta over theta plus 2 square, which I have formed a statement which is exactly shown by the question. A equals to 5,000 theta over 2 plus theta square. I'll state that I have shown the statement. Next question. Find the value of theta such that the area of the sector is maximum. Meaning that the question interested on the theta value, which will make our sector to be, the area of the sector to be maximum. So here, just continue from our statement. Find the dA d theta. Okay, so you can see that this is in the form of a quotient form. I can just apply the quotient function. Let this become the u, and down here become the v. If your u is a 5,000 theta, meaning that a du u prime d, or you say du d theta equals to 5,000, and b equals to theta plus 2 square. So dv d theta, or we in simple form we use a v prime, will be 2 theta plus 2 multiplied by 1. So I got the 2 theta plus 4. Then apply your quotient rule into here to get the dA d theta. We got the vu prime, which v is theta plus 2 square, multiplied by u prime, that will be 5,000. Put a dot here, minus uv prime, which 5,000 theta, multiplied by v prime, that is your 2 theta plus 4. And this will be over v square. V square will be theta plus 2 square. Square, another square will be power of 4. Alright, then we try to simplify first. I have take out the 5,000. Then inside here, I have a theta square plus 4 theta plus 4. I expand this, expand the square, theta plus 2 square, I got this. And minus theta, theta multiplied by 2 theta, I got the 2 theta square, and negative of 4 theta over theta plus 2 power of 4. Simplify further. I got my dA d theta in this form after I simplify the whatever terms in the bracket. Then now to get the A maximum, alright, to get the theta which make up my A maximum, I need to let this equals to 0. So if you let this equals to 0, you might have this. And both sides multiplied by theta plus 2 power of 4, you will have this. And divided by 5,000, you got a 4 minus theta square equals to 0 finally. Then we solve for the theta square equals to 4, theta equals to positive negative 2. Again, the theta is representing the angle subtended in the center of the sector over here. So the theta, it couldn't be negative value. Alright, so we just choose the theta equals to 2 radian. With the theta, it has to be greater than 0, we say. This is the reason we give. Alright, but we're not sure that this theta will either make our A to be maximum or minimum. We need to test with the second derivative test or first derivative test. Since this function, because the dA theta over here seems like very complicated, if I need to differentiate one more time, I choose to check by using the first derivative test. Okay, so I need to sketch the table first. Here I got my dA d theta ready here, and now I need to write down the theta value and the sine of dA d theta, and lastly there is the pattern of the A. Alright, theta, I'm going to test for this value 2 radian. So theta equals to 2, of course the sine will be 0 and the pattern is a horizontal line. If the theta is less than 2, I will going to substitute a value which is very close to 2 but less than 2. For example, I will take a 1.8 or 1.5 or 1.7. Substitute into the dA d theta, see what sign that we get. Substitute the 1.8, maybe 1.8 over here square, you got a negative value which is less than 4. So here you produce positive value, and here of course you produce a positive value because the power of 4. So overall the sign here is positive, and after that substitute a value which is greater than 2. For example, you can substitute 2.1. If you substitute 2.1 over here square, that will be the value which is greater than 4. If you have a sign of negative, then negative of value which is greater than 4 plus 4, that will be producing the negative value. So negative value over here divided by positive, you still will get a negative. So here is a sign of negative. From the sign of the dA d theta, you can see the pattern of A. This is increasing, this is decreasing. And we can make sure that we can just slightly trace the graph, the curve, according to these 3 lines. We can see that at the theta equals to 2, it forms the... So from this result, you can make conclusion that area is maximum when theta equals to radian. Okay, that's it. Alright, let's move to the question 18. Given the u and the v are 2 variables where this is the relation between the u and v, find the maximum value of this u square minus 9v square. Since u square minus 9v square without any representative, so we just let a symbol, we take it p, we take as p equals to u square minus 9v square. This will make our solution later on to be more organized and easy to explain what we are doing. Okay, so now we want to get the maximum value of this, meaning that we want to get the maximum value of p. To get the maximum value of p, you need to get a dp du or dp dv. So you need to make your decision. You want to get a dp with respect to u or with respect to v. So if you want to get a dp dv, I'm going to find the u in terms of v. That is u equals to 5 minus 2v. Substitute this inside, you will have u square, which is minus 5 minus 2v square minus 9v square. Expand it, easy for you to differentiate. You will get a negative 20v plus a 4v square minus 9v square. Simplify further, you get 25 minus 20v minus 5v square. Alright, sorry, this is a negative, yes. After that, I want to get a dp dv. You will have your dp dv as negative 20 minus 10v. And let this equals to 0. You got negative 10v equals to 20, then v equals to 2, negative 2. Alright, so I'm not sure that the v equals to negative 2 will make a p maximum or not. We're not sure. We need to test with the second derivative. Find out the d2p dv2. You got a negative 10. Since the second derivative is always less than 0, we can make conclusion that p is a maximum when the v equals to negative 2. But we are not interested on the V value. We just want to find the maximum value of the P. Okay, so P maximum, we are going to use the expression that involve these in terms of P, which is copy down this, which I have P is in terms of V in this form. And now I'm going to substitute the value -2, V equals to -2 inside. I got 25 minus 20, -2, minus 5, -2 squared. Calculate. After simplify, I got a maximum value of P is 45. Right, this is the last question in optimization problem, which is question 19. A 34-meter length of wire is used to form the shape as shown in the diagram below. This is the diagram shown. And state the relation between the x and y. What does it mean by the relation between the x and y? Means that you need to get an equation that will be that involve the x and y. All right. Now I'm using this information, which the 34-meter length of wire is used to form this shape. Means that the perimeter of this shape will be equals to 34. From here, we can form the relation between the x and y. So what is the perimeter? We have start from here. I got my y plus. Okay, the next one is this x. I go anti-clockwise. Plus x plus 2y plus x plus 4. This is equals to 34. All right, this is equal to 34 meter. And now we simplified it. I have my 3x plus 3y equals to 34 minus 4. You got 30. Simplify further. You have x plus y equals to 10. All right, or you can make your x in terms of y. You have x equals to 10 minus 1. This is the relation between the x and y. And then calculate the maximum area enclosed. So since you need the maximum area, of course you need the expression involve the area. The area, I use the A to represent it. And then the area means that I will separate this diagram or this picture into two parts. The first part is this one, the triangle. How do you get this area of triangle? You're using the formula 1/2 multiplied by the height, that is 4, multiplied by the base. So the base of the triangle is given by 2y minus x. This is the 2y minus x. Alright, so the area of the triangle is 1/2 multiplied by the height multiplied by the base, that is 2y minus x. And plus, you need to add another area, which is the area of this rectangle. The area of the rectangle, very simple. Just take the height multiplied by the base. All right, the length multiplied by the width. That will be x multiplied by 2y. Okay, then we simplify it. Very obviously that now our A expression consists of two variables. Later on, we're going to change into one variable so that we can differentiate. Okay, so multiply, expand it. You have a 4y minus 2x plus 2xy. Now I'm going to make it into single variable by substituting the x equals to 10 minus y inside. I will put into here. All right, 10 minus y. X as a 10 minus y. 10 minus y, put in as a x. And this one the same. 10 minus y multiplied by y. Then all your a will be in terms, your a will be all in terms of y. So now you can find your dA dy, but before that we need to simplify it first. I expand it first. I got 20 plus 2y plus 20y minus 2y squared. 2 multiplied by y multiplied by y, that will be 2y squared. And simplify by combining all the like terms. I got my 6, that will be 26y minus 20 minus 2y squared. All right, then now you can get your dA dy. So dA dy will be 26. All right, differentiate -20, you got 0 minus 4y. To get the A maximum, we need to let the dA dy equals to 0. Then I have this. for y equals to 26 and y equals to 26 over 13 over 2. Alright, so now we're not sure that the y will make our a maximum or minimum. You might test with the second derivative test. Get your d2a dy2. d2a dy2, you got negative 4, means that it's always negative. So our conclusion is a is maximum when the y equals to 13 over 2. Again, refer back to the question. We need to calculate the maximum area. Alright, not the value of y. So what is the a maximum? We need to find out the expression on a, which is over here, 26y minus 20 minus 2y squared. Substitute in. You got 26 minus 20, 26y. Substitute y inside. That is 13 over 2 minus 20 minus 2y squared. With the assist of calculator, you might get the value. Alright, simplify, you get a 64, 1 over 2 meters squared. This is the maximum area. Well, this is the end of the video of optimization problem. Next video, we're going to continue on the rate of change question. Thank you for watching.